So I just wanted to run through 5.2 there, the homework questions that you had. Part A said the chemical bond is formed by the sharing of electrons, a covalent bond, of course. A bond formed from the head-on overlapping is sigma. Two general characteristics of covalent: well, they're usually soft, they usually have low melting and boiling points, they're usually liquid or gases at room temperature, they do not conduct electricity, any of those. You didn't do D, I asked you to leave, I didn't ask you to do D. E, a pair of electrons that are not involved in bonding, well, they're called lone pairs, okay? Lone pairs of electrons are not involved in bonding. And then it says a pi bond is formed from the sideways, is the missing word there, overlap of p orbitals. Give one item of information that might be deduced from the melting point. Well, if the melting point is quite high, then that generally means that the compound is ionic. If it was a low melting point, it would mean the compound is covalent. VSEPR stands for valence shell electron pair repulsion. And then it asks you about the shapes of ammonia. Now, ammonia is NH3, nitrogen is in group 5, so that's 1, 2, 3, 4, 5, and then you're bonding it there to 3 hydrogens. So it's going to be pyramidal. Okay, so the NH3, nitrogen's pyramidal, and then HCl here, so again carbon, okay, 4 electrons, 1, 2, 3, 4, that's your hydrogen there, look, and then you have 3 Cls, and will you draw 7 electrons in the outer shell of the Cls there? So that would be tetrahedral because it's 4 bond pairs, and the other one, the NH3, we said was pyramidal. Predict the shapes of X. Now, we had that already. So because there's 2 bonds, it could either be linear or V-shaped to be your answer for that. K then says, in which of the following is the bond angle 180 degrees? Well, NH3 we had a minute ago. That's pyramidal, so the bonds are squashed close together there. H2O for oxygen. Oxygen is in group 6, so 2 lone pairs would push the bonds quite close together there, okay? BeH2 has an angle of 180 degrees, all right. And then the last one they gave you was sulfur. Now, sulfur is in group 6 as well, look. So when sulfur forms compound there, 2 lone pairs would push the bond pairs closer together. So your answer is BeH2, okay? And then indicate what shape you'd expect the following to have. PCl3, phosphorus is in group 5, 1, 2, 3, 4, 5. Sorry, get rid of that there. And then it's going to bond with 3 of the chlorine, Cl. And remember again, have 7 electrons in the outer shells of the Cls there when you're doing that. So that would be pyramidal. And then CCl4, well, carbon is in group 4, so carbon has 4 electrons in its outer shell, 1, 2, 3, 4. 4 bond pairs there would be tetrahedral. Remember again, for the chlorine, always show the 7 electrons around the chlorine there, okay? 5.3 then, you had part 1 and part 2, possible shapes, okay? Now again, see the 3 there near the X? So that means that it's going to be triangular, planar, or if the X was in group 5 and you had the lone pair here, then it might also be pyramidal, okay? And then it asks you to write the formula of the compound formed in the reaction between chlorine and the metallic element number 31. Now, when you look up 31 in your periodic table, you'll see that it's gallium and it's in group 3. So the fact that it's in group 3, okay, tells me that it has 3 electrons in its outer shell. So it says write the formula of the compound between that and chlorine. Well, 3 electrons in its outer shell, so it's going to form an ion plus 3. Chlorine we know is in group 7, so chlorine is minus 1. So predict the formula. You'll need 3 chlorines, won't you? Because remember we said the charge has to add to give me 0, so it'll be GaCl3. Or another way of knowing there, look, is that, you know, you'll see that when you do that there,